Okay, good morning, good afternoon, good evening. Okay, in physics today, so we're going to look at today is the last topic in this unit 2, and that's power, the cost of power, and also calculating or finding out the power that you have in your legs. Doing a little lab or a little exercise, I guess is what it really is, on that. So we're going to outline that today, and then probably tomorrow I'll give you a chance to. Well, it won't even take you tomorrow. You can probably do it today, actually, to check out your power. Depending on, she'll only take you about 5 minutes. Okay, so we'll let a Blackboard open up, and we'll kind of outline what we're going to do today. This will be our last content day in this unit number 2. Then we'll probably be doing our second hand-in and moving from there in our quiz and so forth, just like the last unit. Of course, this one's a little shorter. Okay. So once our Blackboard opens here, if it ever does, we'll get started. It's a little slow. The unfortunate thing is I can't turn my recording thing on after I turn on my Blackboard. I have to turn my Blackboard on after I turn on the recording. Otherwise, they conflict with each other. Okay, so there we have our Blackboard. So let's kind of look at our outline for today. Okay, what I want to do is pretty simple. Should be fairly short. I want to do 2 things today. So this is day number 15, I believe, or 14. Can't remember. Let me just check here. Sure. We'll go back here and check. Okay, so according to, oops, went too far back. Okay, this will be day 15. So this is day 15, unit 2. Should be our last content day of physics today. I'm not that far ahead of you guys, as you probably can tell when I start putting stuff up online. So this is day 15 of unit 2 in physics. And we're looking at, today we're going to be looking at the cost of electric power. And we're going to also look at the calculating our power. Okay, we can do it in our arms or our legs. We'll do the one with legs because we just do some jumping basically. Okay, so let's start off with the calculating of our power. So we're going to do a little test or a little lab. Should take you a couple minutes each to do, depending on if you're by yourself or whatever. You don't really need to worry too much about things. So put a title: calculating power in our legs over, I don't know, let's say 30 seconds. We could do a stamina type thing too, but I don't want anybody getting injured. We have done in the past where we've done a stamina one where people keep jumping until they can't jump anymore. But sometimes that can be tiring, so we'll just keep it to 30 seconds this time. Okay, so what we need for materials is you need to know a scale in kilograms because you need to know your mass. Okay, we need a meter stick. Okay, we need also a timer. If you're doing it, you could just set your phone to 30 seconds and put it on alarm and then click it when you start jumping. We also need a raised platform. Okay. So basically, that's basically all we need. Okay, so what we're going to do is our process. Okay, is find a raised platform. It's something that's pretty stable that you can jump up on, back down. The other way you can do this is you could use a skipping rope if you want to just jump over the skipping rope and keep jumping over it. That actually might be the safer way to do it. How many times you can jump over it at a certain height, but raised platform will work as well. You can jump on, okay, over the 30 seconds. Or like I said, a skipping rope. If you don't have a platform, you can just put a skipping rope that you jump over and then back, over and then back at a certain height that you got to come up. Okay. Okay, after you find the raised platform, measure the distance it is above the ground. Make sure it's a comfortable distance for you. Here in Vanguard, we just have a couple of steps or whatever, boxes that we can use. Measure the distance the platform is above the ground. Okay. Then what you do, you measure the distance above the ground, is you time yourself for 30 seconds, measuring how many times you can jump onto the platform. In 30 seconds, or you could do time yourself how many times it takes you to do 10 or something like that. Maybe we should do it that way. Well, yeah, let's do it that way. Nah, let's do it the other way. In 30 seconds, you could do it both ways. You could time yourself to do 10, or you could see how many you do in 30 seconds, whatever you like. I'm not a very good jumper myself, so I usually just do 30 seconds because I can probably only get 2 or 3 in. So in 30 seconds, count the number times you can jump on the platform. Again, I mentioned you can also use a skipping rope if you don't want to jump on top of something. You can just jump over it, just hold it at a certain height, between 2 chairs, and then jump back and forth over it. Try not to trip on it. Okay? And that's basically all you have to do. So then we'll do the analysis. Okay? Is you calculate the energy output and divide by the time. And that'll give you your power rating for your legs in watts. Okay, so let's do an example. Let's say that we were jumping onto, something that was 75 centimeters high. It's pretty high. Let's say something that was 50 centimeters high. So let's say our step height was equal to, let's say, 50 centimeters. Let's say 52 centimeters. So if we change that into meters, that would be 0.52 meters. And let's say that we did 11 jumps in 30 seconds. And let's say that my mass in kilograms was, what do I weigh here? I weigh about 200. So let's see. Divided by, say that I was 88 kilograms. Okay, so there's my results that I took from my trial. Of course, you could try it a few times. You could also do this with your arms as well. If you had a dumbbell, you could do some dumbbell curls and see how many you can do in a certain amount of time. But this one's the easiest one to do with legs. Okay, so let's take our marker and do our calculation of power. So how to calculate the power. So the first step, so let me get my marker out here first. There we are. Okay, so let's move it up. Let's keep that in view. Okay, so first thing you have to do is get your total height that you did jumping. Okay, sometimes people do this jumping upstairs or climbing stairs. Running stairs is another way you can do a power test, or running on a ramp. If you have enough stairways to run up, you could see how long it takes you to run stairs. And each stairway, you measure the height. So there's another way you can do it if you have stairs in your school. Okay, so let's say step one, calculate the total height. Oops. Okay, so the total height that you jumped, so in my case, we got 11 at 0.52 meters, probably each time, times 11 reps. Okay, so then if you take your calculator and multiply that out, that's going to give you the total number of times you jumped up against gravity. Just going to answer this quick here. Okay, let's go ahead and do that. 0.52 times 11. So in my case, I got 5.72 meters. Okay, so once you calculate the total height, the next thing is to calculate the gravitational potential energy that you worked against, because that's what you would be producing as the energy. So step two is get your energy output. So calculate your energy output. Okay, so our energy output would be gravitational potential energy, because we're jumping up against gravity. So that would be mgh. So in my case, my mass is 88 kilograms. Okay. If you were doing curls with your arms or something, that would be whatever that was. Gravitational energy is 9.8 newtons per kilogram. And the height, total height, because I did it 11 times, 5.72 meters. This is going to give me my joules of energy. So I take my calculator out and I calculate that. Okay, so multiply those three things together. 88.9.8 times 5.72. And I get 4,932.98 or 0.928 joules. I'm just going to go 0.9 joules. Okay, and that gives us our energy output. And then finally, if we want to get our power, step three is calculate the power. Okay, so the power, if we remember, power equals a change in energy over time. So we went producing 4,932.9 joules divided by our 30 seconds. So 1 joule per second is a watt, so we're going to get watts here. So divide this by 30. And we get 164 watts of power. So that's what the power production for that 30-second jumping session would have been. Okay. Obviously, as a human body, your power goes down as you get fatigued, right? So the longer you do that, the less power you would end up doing. We've done total energy output per time. We also have done this with chin-ups as well. So if you wanted to do chin-ups, you could get a chin-up bar and then find the power of your arms as well, by how many pull-ups you can do. And you got to make sure that you extend yourself totally so that you're pulling the same distance every time. How many pull-ups you can do in 30 seconds. That's another way to do this for arms. So if you wanted to try arms and you have a chin-up bar, you could do that. Legs, you could do jumping on something. Legs, you could also do climbing upstairs. For arms, you could do power curls as well. So there's all kinds of different ways of doing power calculations. That's just one example of it. Okay, so that's power. The other thing I want to do is cost of electric power. They used to have an electricity section in physics. They took it out mainly, and you see a little bit of it in the fields unit, which we do next. But it's still important to be able to calculate power. So that'll be the second thing that we look at today. I'm just going to put this on pause here because I got another email here to answer, and then I'll come back and we'll get into that second part. Okay, good. Let's continue on here. So that was our example of calculating power. And like I said, there's different ways you can do it. So now we're going to look at the cost of electricity in our last section today. Okay, so cost of electricity, it's a little bit different. Okay, so when you talk about electric power, that's our title, electric power cost. So if you rearrange the energy equation, if you rearrange the power equation, okay, so if you take power, which was energy over time, okay, and we want to get energy by itself. If we rearrange it for energy, energy is equal to power times time. Now, what energy is charged in, electric energy, it's charged in this unit here. It's not this unit here. They don't give you it in joules. Okay? So they charge it in kilowatt hours. Okay? So this unit is in kilowatts, and this unit is in hours, because 1 joule is such a small energy unit. So we know that normally 1 joule is 1 watt, is 1 joule per second. Okay, so if we're doing kilowatt hours, if we think about how many kilowatt hours, there's 1,000 watts per kilowatt and 3,600 seconds per hour. So if we multiply those two together, 1,000 watts or joules per second times 3,600 seconds, that's going to give us 3,600,000 joules per kilowatt hour. Okay, so that's the reason why. So the reason why they do that is because a joule is such a small unit of energy that, in terms of what we use for electric energy, for example, 1 kilowatt hour costs about 15 cents in Saskatchewan right now. Okay, so, and 1 kilowatt hour would run your fridge for a few hours, because your fridge is not a kilowatt. It's usually a couple hundred watts. Okay, so that's one of the reasons they use the kilowatt hour for the electric cost type calculation. So let's do some examples of doing cost of electricity here. Okay, so let's say that I didn't look it up before today, but say that a couple of years ago anyways, it was about 13.2 cents a kilowatt hour, but I think it went up. So let's say that the cost of electricity is equal to, say, 14.5 cents or $0.145 per kilowatt hour. Okay. If my fridge, let's do an example question to calculate a power. Okay, so if my fridge motor and compressor consume 150 watts, we'll say, how much money do I spend running my fridge for a year? So how much money does it cost to run the fridge, power the fridge, we'll say, for a year? So what you want to do is you want to figure out how many kilowatt hours you're going to consume in a year. Okay, so the first thing you got to do is change the power of the fridge into kilowatts. So convert the power of the fridge into kilowatts. Okay, so 1,000 watts per kilowatt, so it's 150 watts divided by 1,000 watts per kilowatt, which equals 0.150 kilowatts. Okay, so canceling out the watts. Okay, so then we have to figure out the time that your fridge would run for a year. So calculate the number of hours in a year. Because we want kilowatt hours, right? Okay, so 1 year times 365 days per year. So that cancels out that, times 24 hours in a day. Okay, so if we multiply 1 year by 365 days and then that by 24, we should get how many hours we have in a year. So let's do that. 365, guess we could, times 24. So we got 8,760 hours in a year. Okay, that's a year. Okay, so now we have both the time and the output. We have the kilowatts and we have the hours. So now we have to multiply them together to get the kilowatt hours, or the rating of our consumption of power in kilowatt hours, not in joules, but in kilowatt hours. So now we calculate the kilowatt hours. Calculate the energy used. Okay, in kW hours. So energy equals power times time. So in our case, the power was 0.105 kilowatts times 8,760 hours. Take those two numbers together to get our kilowatt hours. So 0.15 times 8,760 gives us 1,314 kilowatt hours. That's how much kilowatt hours we're going to consume with our fridge. Okay, that doesn't give us the cost. Now we have to multiply the kilowatt hours by the cost. Okay, so then find the cost. So we do price times number of kilowatt hours. Okay, so that would be 1,314 kilowatts hours times 0.145. There's no decimal there. Sorry, $145 per kilowatt hour. Okay, which I think is approximately where the price of electricity is right now. It's supposed to be going up a little bit, but so 1314 times 0.145. So I get $190.53 per year. For the cost of running that fridge. So that's an example of doing a question for cost of electricity. Okay, that's one basic type. Okay, so sometimes they'll have cost of electricity questions that are ones where you're going to have to work backwards. They might give you a price instead. So let's do one like that. Okay, so this one will be a backwards one, or working backwards. So let's say, how many hours of power consumption can I expect from $20? Okay, $20. If someone will say, because I can uses a 1,500 watt hair dryer. Okay. So in this case, we're working backwards. So we have, and we're going to, the cost is going to still be, we're still going to have cost of electricity being $145 per kilowatt hour. Okay. Okay, so let's do this. This is working backwards. So we start with the cost, and we've got to go to kilowatt. So what we got to do is we got to break the cost into how many kilowatt hours we'd have, and then we got to take the kilowatt hours, use the formula, plug in the kilowatt hours and the kilowatts for the implement, and find out what the time would be. Okay, so step one: how many kilowatts is 1,500 watts? So convert 1,500 watts to kilowatts. So we're dividing by 1,000. So that'd be 1,500 and we get 1.5 kilowatts. Okay. Step two would be then to find out, convert the cost, okay, into kilowatt hours. Find the kilowatt hours. You can buy for $20. Okay, so we take our cost. The last one was kilowatt hours times price gives you the cost. So cost divided by kilowatt hours divided by kilowatt hours, or price, pardon me, not kilowatt hours, will equal the kilowatt hours. Okay, so if we do that on our calculator, I get 137.9 kilowatt hours. Okay, so that's how much I can get for $20 at that current price. Okay, so then I have to figure out the time. So the last thing is calculate the time. Okay, how many hours do you get for $20 of that using that implement? So the energy equals power times time. Okay, our energy is so many kilowatt hours. Okay, our power of our implement was 1.5 kilowatts, and our time is blank. So we have to divide both sides by 1.5. So take your answer that you had and divide by 1.5. Okay, and I get 91.95. So if we go to two significant figures, we get 92 hours. So it's going to be about 92 hours of time for you to use up the $20 using your hair dryer on full. Okay, so that's not bad. Okay, and to think cost of power in Saskatchewan is higher than most other places that have running water and hydro and things like that, because that's cheaper to make. Our power is pretty high. Okay, so that is basically the cost of power going backwards. Okay, so it's about 32 minutes. I'm going to do one more combination and then we'll call it a day here. So let's do one more. Let's do one where we have two implements or more, and then we'll call it a day. And the next day, I'm going to give you your hand in for the unit. Okay. So let's say that a TV or a monitor is rated at 150 watts. Computer is rated at 350 watts. If the cost of electricity is the same price that we have there, per kilowatt hour, find the I guess this is the price of electricity. It's not really a cost, right? So we'll use the word price. The price of electricity is so much per kilowatt hour. Find the cost running your computer, running both for a week. You to try that on your own. So you can pause it and try that, and then I'll be working it out here in a minute. And that'll be it for today. That'll be about in that 35-minute range for lecture. And then we'll get into the hand-in part for next day. Okay, so the cost, if you run paused, so we've got 150 watts for monitor plus 350 watts for the computer. Okay, so that's going to give us a total of 500 watts total. Okay, we got 500 watts total. So we have to change that into kilowatts. So divide by 1,000, or move your decimal over 3. So this would be equal to 0.500 kilowatts. Okay, now we have to find out how many hours are in a week. So we've got 7 days a week times 24 hours in a day to give us 168. Okay, 168 hours. Okay, so then we now get our energy consumption by multiplying the power times the time. 0.500 kilowatts times 168 hours. So that's going to give us half that, or 84 kilowatt hours. Okay, so we've got 84 kilowatt hours. We multiply that by 0.145 kilowatt hours. $0.145 per kilowatt hour. Times. So I end up getting $12.18. Okay, and that's a good stopping point for us today in physics. Okay, and we're done this unit now. So if you're still got extra time here today, I'll probably have the hand in. I'll open that up underneath in our next little section here. And then, of course, the next day, I'll give you a couple days to work on that. And then I'll give you the outline or quiz outline, and then we'll get that set up as well. Okay, so that's where we're going to stop today.